In the world of heavy machinery, power and performance are everything. But today, there's a new challenge: sustainability. And now, two global giants, Komatsu and Cummins, have teamed up to create a hybrid system that's about to change the game. What makes this collaboration unique is the combination of Komatsu's expertise in designing and manufacturing heavy equipment with Cummins' leadership in engines and hybrid powertrains. Together, they are addressing one of the biggest challenges in industries like mining and construction: how to balance raw power and reliability with sustainability and efficiency. By integrating hybrid technologies into large-scale equipment, they are redefining what heavy machinery can achieve. One of their key projects is the development of zero-emissions mining haul trucks. Komatsu and Cummins have entered into a formal partnership, signing a MOU to jointly develop mining haul trucks that can operate with zero emissions. This collaboration is focused on one of the most challenging sectors to decarbonize: ultra-class haul trucks used in large-scale mining operations. These trucks are massive, often carrying 200 to 400 tons of payload, and they consume huge amounts of diesel fuel every year. By targeting this category of equipment, Komatsu and Cummins are addressing one of the biggest contributors to greenhouse gas emissions in the mining industry. One of the leading technologies under development is the use of hydrogen fuel cells. A fuel cell works by combining hydrogen with oxygen from the air to produce electricity. This electricity then powers the truck's electric drive system, moving the vehicle forward. The only byproduct of this chemical reaction, when properly managed, is water vapor, making it a truly zero-emissions technology. For heavy equipment, fuel cells are attractive because they can deliver high power output, quick refueling compared to batteries, and long operating ranges, all of which are essential for large mining fleets working continuously in demanding environments. To ensure maximum flexibility for operators, Komatsu has also introduced the idea of a power-agnostic truck platform. Instead of designing a truck around one fixed energy source, the chassis and systems are being engineered to accept multiple powertrain options. These options could include diesel-electric systems, with cleaner fuels or hybrid support, battery-electric systems for short-cycle operations, hydrogen fuel cells for longer-range zero-emissions applications, or even trolley-assist systems, where trucks draw power directly from overhead lines on certain routes, much like an electric train. This modular, flexible approach is critical because mining operations vary widely in geography, infrastructure, and energy availability. For example, a mine in a remote desert might not yet have hydrogen supply chains, but could use trolley assist, while another in a region investing in hydrogen production might move directly to fuel cell-powered fleets. By offering a power-agnostic design, Komatsu and Cummins give customers the ability to adopt cleaner technologies at their own pace, while ensuring that their investment in haul truck platforms remains future-proof. In short, the development of zero emissions haul trucks is not just about replacing diesel engines with new power sources. It's about creating a flexible foundation for the mining industry's energy transition. This initiative aims to deliver trucks that meet the twin goals of performance and sustainability, while giving mining companies the tools they need to reduce their carbon footprint in a practical, adaptable way. Another major focus of the Komatsu-Cummins partnership is the development of dual-fuel engines for ultra-class mining haul trucks, in collaboration with Vale, one of the world's largest mining companies. Because of their size and constant duty cycles, even a single truck can burn through thousands of liters of diesel fuel per week, making them a critical target for emission reduction strategies. The dual-fuel system being developed allows these engines to run on a blend of ethanol and diesel, with ethanol making up to 70% of the total fuel mix. Ethanol, especially when produced from renewable sources such as sugarcane or biomass, has a much lower carbon footprint compared to fossil diesel. By replacing the majority of diesel with ethanol, the trucks can cut direct CO2 emissions by up to 70%, significantly reducing the environmental impact without sacrificing the performance and reliability required for mining operations. From a technical standpoint, the challenge lies in adapting large, high-powered diesel engines to operate efficiently and safely on a dual-fuel mixture. This requires precise engine control systems that can optimize combustion depending on the ratio of ethanol to diesel, as well as adjustments to fuel injection, ignition timing, and thermal management. Cummins' expertise in engine design and fuel systems plays a central role here, ensuring that performance, durability, and safety standards are maintained. The advantage of dual-fuel engines is that they provide a practical, transitional solution for decarbonization. Unlike full battery electric or hydrogen systems, which require major new infrastructure, dual-fuel haul trucks can be integrated into existing fleets with relatively modest changes. For example, ethanol is already widely available in countries like Brazil, where Vale operates, making it an immediately viable fuel option. This allows mining companies to start cutting emissions now, rather than waiting years for new zero-emission technologies and infrastructure to be fully established. In addition to reducing emissions, dual-fuel systems help extend the life of existing mining fleets. Instead of replacing entire trucks with new powertrain technologies, operators can retrofit current vehicles with dual-fuel engines, lowering costs while still making measurable progress towards sustainability goals. This approach also gives mines the flexibility to adjust the fuel mix based on availability and economics, ensuring continuous operations even if ethanol supply fluctuates. Overall, the dual-fuel program with Vale demonstrates how Komatsu and Cummins are tackling the decarbonization challenge from multiple angles. While hydrogen and battery systems represent the long-term future, dual-fuel technology provides a powerful bridge, cutting emissions substantially in the short term while leveraging the existing infrastructure and fleet investments that mining companies depend on. Komatsu and Cummins are also focusing on hybrid powertrains and energy recovery systems as part of their joint effort to decarbonize mining operations. In large haul trucks, enormous amounts of energy are lost during operations, especially when braking. For instance, when a fully loaded mining truck, often weighing hundreds of tons, travels downhill, its brakes generate heat as they slow the vehicle. In conventional trucks, this energy is simply wasted. Hybrid systems aim to capture that energy, store it in a battery, ultracapacitor, or other storage device, and then reuse it when the truck needs extra power, such as climbing uphill or accelerating under load. This concept is often compared to regenerative braking in cars, but the scale is far greater in mining. A single downhill run in a haul truck can generate megawatts of braking energy, enough to meaningfully offset the fuel consumption of the next uphill haul. By reusing this energy, hybrid trucks can reduce diesel consumption, cut emissions, and improve overall efficiency. At the same time, they lessen the strain on the primary engine and braking systems, which helps reduce wear, extend component life, and lower maintenance costs. A key enabler of this initiative is Cummins' acquisition of First Mode in early 2025. First Mode is a technology company specializing in hybrid retrofits for heavy industries like mining and rail. Their expertise allows existing diesel haul trucks to be upgraded with hybrid energy recovery systems, rather than waiting for entirely new fleets to be built. This means that mines can begin adopting hybrid retrofits immediately, gaining fuel and emission savings without the high upfront cost of replacing trucks. Hybrid technology also plays a critical role in Komatsu's power-agnostic haul truck strategy. Whether the main energy source is diesel, hydrogen fuel cells, or full battery electric, hybrid energy recovery adds value. For hydrogen trucks, capturing downhill energy can reduce the demand on the fuel cell and extend range. For battery electric trucks, regenerative braking is essential to maximize efficiency and keep operations practical in large open-pit mines. By working together, Komatsu and Cummins are positioning hybrid and energy recovery systems as a bridge technology. While the industry gradually transitions to full zero-emission haulage, hybrids allow companies to cut fuel use and emissions right now. At the same time, these systems improve truck performance, making them not just cleaner, but also more cost-effective and reliable for day-to-day mining operations. Another important pillar of the Komatsu-Cummins collaboration is the development of integrated remote monitoring and analytics systems for mining equipment. Modern haul trucks and heavy machinery are highly complex, combining Komatsu's chassis, hydraulics, and control systems with Cummins engines and advanced power systems. By enabling both companies to share data in real time, they can create a unified picture of machine health, performance, and efficiency. Traditionally, equipment manufacturers and engine suppliers have maintained separate monitoring systems. This often left mining operators with fragmented information. One system tracking the truck's structural and hydraulic health, and another tracking the engine and powertrain. Komatsu and Cummins aim to break down this barrier by linking data from both domains. This allows them to monitor everything from fuel efficiency, thermal loads, and battery state of charge to suspension performance, braking energy recovery, and even operator behavior. The integration is especially powerful when combined with predictive analytics. Using advanced algorithms and machine learning, these systems can spot patterns in the data that indicate potential failures before they happen. For example, a subtle change in vibration or temperature in the engine might signal a future bearing issue, while unusual load patterns in the chassis could point to structural stress. By detecting such signals early, operators can schedule planned maintenance rather than dealing with costly and disruptive breakdowns in the middle of operations. This approach not only reduces unplanned downtime, but also helps extend the life of components, optimize fuel or energy use, and improve overall fleet productivity. For mining companies, where uptime is critical and trucks often run 24/7, even small improvements in reliability and efficiency translate into significant cost savings. The data sharing framework also supports continuous improvement. By analyzing large data sets across multiple sites, Komatsu and Cummins can refine truck and engine designs, improve software updates, and tailor maintenance programs to specific mine conditions. Over time, this creates a feedback loop that makes each generation of trucks smarter, more reliable, and more efficient than the last. In essence, the integration of monitoring, data, and maintenance systems represents a shift from reactive equipment management, fixing things when they break, to proactive and predictive fleet optimization. It combines Komatsu's role as the machine integrator with Cummins' deep knowledge of engines and power systems, delivering a holistic, data-driven solution that benefits both equipment operators and the broader mining industry. In summary, the Komatsu-Cummins partnership is more than just a technology showcase. It's a roadmap for how mining can move toward a cleaner and smarter future. From zero-emission haul trucks using hydrogen fuel cells, to dual-fuel engines that drastically cut CO2 with ethanol, to hybrid systems that recover wasted energy, and predictive maintenance tools that keep machines running longer with fewer breakdowns, every project is designed to balance sustainability with performance. What makes this approach unique is its practicality. Mines don't need to replace entire fleets overnight. Instead, bridge solutions like hybrid retrofits and dual-fuel upgrades allow existing equipment to become cleaner today, while power-agnostic platforms keep fleets adaptable to tomorrow's fuels and technologies. The result is lower emissions, reduced fuel use, smarter maintenance, and equipment that's flexible enough to thrive as energy infrastructure evolves. A strategy that keeps mining efficient, competitive, and ready for the low-carbon future. Finally, we've reached the end of this video. If you enjoyed it and want to explore more content like this, don't forget to hit the like button and subscribe to the channel. It really helps us grow and bring you even more exciting topics.